In this hypothesis testing, we randomly selected 15 students among our top 30 peak students in our group to be interviewed in grade 11 STEM only. After conducting the interview, we have now gathered our data and can now find our mean and standard deviation. And by multiplying and adding, dividing, we find out that our mean for our problem is 33.6, while our standard deviation is 5.984.
It is claimed that the grade 11 STEM students in reading and writing preliminary test scores is 35. A researcher selected random sample of 15 students in SRCB. The computation of the students that was interviewed resulted in an average test scores of 33.6 with a standard deviation of 5.984. Does this mean that the reading and writing preliminary test scores of a grade 11 STEM student is less than 35? Use 0.05 level of significance and assuming that the following population is normal.
The null hypothesis is 35, and the alternative hypothesis is less than 35.
Based on our word problem, we can see that the use of significance would be 0.05.
In step 3, which is the computation part, we will use a t-tabular formula since we are given a sample size of 15. And then we get t is equals to 33.6 minus 35 over 5.984 over the square root of 15. Then we equate first the sample mean minus the population mean, which we get a negative 1.4 value. Next is we equate the sample standard deviation and the square root of the sample size, which we get 1.55. And lastly, we compute negative 1.4 divided by 1.55, and we get t-tabular computation equals to negative 0.90.
So we have now here the step 4, which is to determine the critical value. So by getting the critical value is first we have to identify the level of significance and the degree of freedom. So we have here the level of significance is 0.05, and before we get the degree of freedom is first we have to use this formula, which is the degrees of freedom equals to n minus 1. So n is meaning the sample size. So by calculating it, we have to get the degrees of freedom through 15 minus 1. So we have now here the 14 by the degrees of freedom. So as you can see here, by getting the critical values is we connected the degrees of freedom and in the level of significance. As you can see here, the 0.05 is below the area in 1 till because based on the given denotation, the alternative hypothesis there is we have the less than sign. Just to remember that when we have the alternative hypothesis of having the less than or greater than sign, we can only use that through the t-test, whereas having the not equal sign in the alternative hypothesis, we can only use that in the z-test. So as you can see here, through connecting, we have here the 1.761. So therefore in the t critical values is we have the 1.761 at 5% of level of significance. The critical values is negative 1.761 because we determine through it the left tail test or the one tail test. Through graphing, we apply the t-tab critical value and the t computation. So as you can see here, the t-test or the t computation does not fall in the critical values.
We cannot reject the null hypothesis that the average test score of the 15 students from SRCB is equal to or greater than 35. Therefore, we cannot claim that the reading and writing preliminary test scores of a grade 11 students is less than 35 based on the sample data provided.